So mapping. Uh, the first thing you need to know as a student is that when we are talking about mapping, what does it mean? When we are talking about function, what does it mean? So first thing you need to know is you need to differentiate between what we mean by function and relation, because most students have problem when talking with when talking about function. They always regard all the relation to function, and they always regard all function to as a relation. So, but in this video, what I'm going to do is that I'm going to explain the difference between what? Difference between function and relation. Also, in this video, what we need to learn, there are things we want to know in this video. The first thing, as a student, that you must know is you need to know the difference between function and relation in mathematics and relation. That's the first thing we need to know. Also, we want to know what is mapping. What is what? Mapping. And everything that mapping entails. As well, we want to know types of mapping. Types of mapping. Therefore, we need to know what we call composite mapping. Composite mapping is not a type but a division of mapping. Then the last thing you need to know is inverse of a mapping. Inverse of mapping. So as high level students, if you have known all this very well, like you know them very well, I think you don't have problem with what we call mapping and function again. So let's start. In mathematics, function can be anything. Function can be what? Anything. So far that particular thing is having input, is also having output. The same thing relation. Relation can also be anything. So far that it has input and it has what? Output. You get? Now, as related to mathematics, what is the difference between function and relation? You get? So when we are talking about relation, let's say we have y equals to function of x. Y equals to function of x. In mathematics, this is a function. You get? But some people will call it relation sometimes. But what will make it unique that okay, this is a function, and what will make it unique that this is a relation? You get? There are basic two things to differentiate. You get? A relation, you understand, it contain input and output. Like this one is input, this one is what? Output. You get? It contain input and it contain what? Output. But a relation doesn't contain one input or one output. Rather, relation sometimes doesn't contain what? One output. Most of the relations contain more than one output. Like for example, let's say I give you something like this. AB, CD for this particular set. This is a set like this. Then I also have another one which is 1, 2, 3, 4. Then I have 1, 2. No, let me say 1, 4. So let's consider this particular two things. Let's call this one x and let's call this one set. Let's call this one set x and let's call this one set y. So I want to use these two to differentiate between what we mean by expression, function and relation. Pause here. So using this to differentiate between function. Now, if you look at this, in this place, you can see that this is a coordinate. This is also a coordinate. So you can see that for this one, this is coordinate x, this is y, this is 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 x, this is y, right? So let's now say I want to express it in form of something like this. Though I have not reached mapping, but I will not reach it. So let's say for x, I'm having a, this is another x, I'm having c, this is another x, I'm having 1, this is another x, I'm having 3. So and this is another x which I'm having what? 1. So I don't need to write it twice. I can't write it twice. Then I also have this x and this y. So for my y, I'm having b. The second one I'm having d. The third one I'm having 2. I'm having 4. Now, if at the end of the day I represent this, you get, I represent this, and I say okay, this is goes to this, this goes to this, this goes to this, this goes to this, or okay, sorry, or you do it like this in a professional way. Okay, your a, which is what, x, abi, a which is x, goes to what, goes to what I have here, it goes to what, it goes to 2, you get. So a goes to 2, then c here goes to what, goes to 4, right, goes to 4. Then what other things again? We are having, okay, 1 here, right? It goes to what? Goes to which one? 4 again. So this one also goes to 4. Now, if they now ask you, is this one a function or a relation? You said that this one is a what? Is a relation, it's not a function. Why? Because a relation has more than 2 what? Outputs, and a function only have what? 1 unique output. So if you look at this now, there's where you're having 2 what? 2 outcomes, you get, like from different inputs. This input is now having what is it called? Is mounted on what? On 1 what? Output, but it's from different inputs, you get. So that means 2 inputs giving what? 1 output. That's a relation. You can also have one input giving 2 or more outputs. That's relation. But when you are talking about function must be what? Attached to its unique outputs. You understand? So that's the difference between relation and what? And function. So let me see if I can have another example to back up this so that we can understand better. Aha. So let's look at this question. Let's look at this. So let's see this question. The question is like this. We are having A, set A. We are having minus 3, comma 4, minus 3, comma 4. We have 0, comma 5, and we are having 2, comma 1. So, and we are having another set which is B. We are having minus 2 comma 4, minus 2 comma 4, we are having 1 comma 3. So this is another example. We are having another example, which is this is set A and this is set B. So we are having 1 comma 3, we are having 3 comma minus 2, and the last one, okay, 2 minus 2 comma 4, 1 comma 3, then minus 2 comma 7, minus 2 comma 7. So this is what you are having. Now, for these two questions, they're now asking us which one is a function and which one is a relation. Which one is a function and which one is a relation. So this is very simple. For this first set, you understand? You are going to write it out in what? In its domain and range form. So the definition of domain, codomain and range, I will later be giving you when I'm defining what we mean by mapping. You get? So I will later be giving you the definition in comprehensive. But how will you write it out? So the domain here, for this one, for this A, you are having minus 3, minus 3 comma 4, right? 0 comma what? Comma 5, then 2 comma what? 1. If I'm not mistaken, let me check. Minus 3 comma 0, minus 3 comma 0, 0 comma 5, and 2 comma 1. So look at this. Minus 3 comma 4, minus 3 comma 4. So for this one, you can see that x, y, x, y, x, y. So your domain in this case will be your x. So your domain in this case will be your x, which are D. Domain will be something like this. You use a square bracket. You have minus 3 comma 0 comma what? 2. Then your range will be your y. So I later give you the definition of domain, codomain, and range. Then your domain will be your y, which is what? 4, 5, and 1. So now you can see that for x, which is minus 3, it's having the what? Y, right? So this one is having this, right? For this one, which is 0, it's having what? But it's always good. You can see I write it as 4, 5, comma 1. In arrangement, it's always good to write it in what? Ascending order, like 1, 4, and what? 5. You see the same thing. It's always good like this. So minus 3 to what? 4, then 0 to what? To 5. 0 to 5, right? Then what? 2 to what? To 1. 2 to 1. You can see that each of the domain has a what? Each what? Outputs. Each what? Outputs. So in this case, you call this a what? A function. This is a function, not a relation. But now look at the second one, which is this. So this is what? X, this is y, right? X, y, x, y, x what? Y. Now I want to write all the x out, which will give my domain. So we are having minus 2, right? Minus 2, 1, 3, minus 2. So I'll start from minus 2, right? 1, 1, and what? And 3. Because I cannot write minus 2, I cannot write twice. So then your range, I'm going to have 4, you have 4, 3, minus 2, and what? 7. You start from minus 2, Then which one again? 3, 4, and what? 7. You can see that minus 2 is marked to what? Is marked to what? 4. 1 is marked to what? 3. 3 is marked to what? Minus 2. And minus 2 is also marked to what? 7. Now look at this. Look at this. So now you having your domain having how many words? Range 2. Is not your domain, which is one output. This input like this line is input. Is giving how many outputs? 2. Is giving 2 outputs. So this is not a what? A function. This is what? A relation. This is a relation. So relation always have what? More than what? One output. You get? Or more than one input. So you can have more than one input. Let's say 2 inputs give 1 output, or 1 input give more than 2 outputs. That's what we mean by function and range. So I hope you get the difference clear now. So that's the basic difference between function and what? Relation. Now, what do you now mean by mapping? Let's go to mapping. I think we have got the difference between this and this. Let's now go to mapping. You see the function is actually what we need here. We don't actually need relation, but I just need to define or differentiate between them for you. You now see a function that has an assigned rule. A function that has what? An assigned rule. Or you say a function that has a mathematical assigned rule is what we mean by mapping. For example, let's say as you are giving this now, and I want to know the rule that guides this function. Of course, I know this is a function, right? I know this is a function. This one that I first did is a function. Like d minus 3, 0, 2, domain, then range 4, 5. I know these two, these are what? These are functions based on the explanation that I've done, right? Now, I now want to know the rule that make from this place that give this one. Your rule can be linear. It can be linear equation. Your rule can be what? Linear equation. Your rule can be quadratic equation. Can be quadratic equation. Your rule can be polynomial equation. Polynomial equation. And your rule can be higher equations. Higher equations. But based on your foreign level and at basics, you always deal with either linear and quadratic. Most of functions that you'll be giving are always either linear or quadratic. So if this, you know that we are having minus 3 here, we want to know which rule gives this one. You know we are having one here. We want to know what are we going to have as rule. That when we put minus 3, we are going to have 1 as our range. That's the meaning of mapping. That means you are having an assigned rule. So let me start with, let's say I start with x plus 1. This is a linear, right? This is a linear equation. So if I put minus 3 here, am I going to have 1? If you say minus 3 plus 1, you have what? Minus 2. So you are now having minus 2 here. What you are having is what? Is 1. So that means x plus 1 it doesn't go, right? Let's say I have x minus 1. So if I put minus 3 here, I have minus 3 minus 1, you have minus 4. And of which what you have here is what? Is 1. So this is not the rule. So let's say I put I say x plus 2. That's how you'll be assuming x plus 2, right? So if I say x plus 2, what do you have here? You're going to have what? X is minus 3, right? Plus 2. Minus 3 plus 2 is what? Is minus 1. But what you're having here is what? Is 1. So this rule also doesn't what? Doesn't go. So but let's say I have minus x plus 1. If I have minus x plus 1 as well, you're not going to have 1. Because you are going to have minus 3, minus times minus 3, which is plus 3. Plus 3 plus 1, you have 4. So you don't have something like this too. So what if I have So I'm still assuming rule, but in linear form. Some rule can be quadratic, depends, and you are the one that will think of that. So let's say I have minus, okay, let's say I have 2x 2x plus 3, 2x plus 3. So okay, 2x plus 3 also cannot work. 2x plus 3 also cannot work. But let's say I have 2x plus 1. 2x plus 1. Are we going to have minus 1? No. Let's continue. We can get the rule. We can get the rule. Okay. Alright, let me find something like this. We have minus okay, minus, okay, let's have 1 over 3 minus 1 over 3 x1 x plus 1 over 3 x plus 2 over 3x plus 2. So let's say function of x is divided by 1 over 3x plus 2. Look at this. This is 1 over 3, right? So we say 1 over 3 times minus 3 plus 2. Minus, so this, you cancel this, you have minus 1 plus 2. Abi? Minus 1 plus 2 is what? 1. You can see that this is a rule that I assigned. I've assigned a rule now that actually what? Fits this. But you have to know that the rule that you are assigning, must always go for everything. If you put minus 3 here and give you 1, you must also make sure that when you put 0 there, you get your 4. When you put 2 here, you must get your what? 5. But when we are solving more questions now, you see, this one is just an example, you understand? So I'm just trying to show you that a mapping is a mathematical rule to a function. Any function that has a mathematical rule. So most of the time you see a question under mapping that say a mapping is divided by f of x such that x is equals to maybe 3x plus 1 plus something like that. They now ask you to find the range, or they ask you to find the codomain or anything. You get? So it actually comes from what? From all this. So all those things, all those questions that you always see like that is a what? Is a mapping, because it already has an assigned rule which is linear. Some question might come in quadratic, some question might come in what? Polynomial. You understand? So in short, a mapping is a what? Is a function that has a mathematical rule. You get? So if A is mapped to B, there must be a rule that guide what? A to what? To B, for it to be a what? A mapping. So that's the definition. So in short, you have known the difference between function and relation, and you have known what we mean by what? Mapping. Now, before we move to what's it called? Types of mapping, let's define all these things. The first thing you want to define is domain. You need to know the definition of what we mean by domain, and you need to know what we mean by codomain and range. Domain, D, range, R, and codomain. Codomain. codomain C. So in mapping and function, when you are talking about domain is actually the image that you are considering, the image you are taking into consideration. You get? Domain is actually what? Image. You understand? So what you want to map into another function, what you want to map into another set. That's what we mean by domain. Domain is actually what? The image of a particular set. To the image to be mapped to another set. That's what we mean by domain. You get? So while the range is actually, let me use this for example. Let's say you have this x, you have this y. Your domain is this. This is the image. This is the what? Image. You understand? Now, the image is what you want to map to another set. This another set that you are mapping into is what we call the codomain. Co-what? Domain. Or you call it what? The P-image. You get? So this is what? The domain. So this is what? The codomain. So the domain is always mapped to what? Codomain. Now, let's now say I am having A, B, C, D. Then I'm having E, F, G, H. Let's say I'm now having something like this. I want to explain range now. I've explained what we mean by domain and codomain. So codomain is your image. You get? That's the particular set. You get? So codomain are the what? Are the pre-image. So what is being mapped to? So this one is what you are mapping into another thing. Now, you see those elements that I have here, they have image in the domain, is called the what? The range. It's called what? The range. How many elements here are you having that have image? You have 1, 2, 3, 4, right? You can see that this comes here, this comes here, this comes here, this also comes here like this. So it means all these things like this are your range. So in short, range is defined as the elements that are having image in the what? In the domain. The elements that are having image in the what? In the domain. That is those ones that have a map in the what? In the domain. That's what we mean by what? Range. So if I ask you how many range do you have here? So your range here, your range is what? E, F, G, H. But if I ask you the codomain will be E, F, G, H, I. You get? I is not mapped to anything. I is not mapped to what? Anything. So that is why it is what? It is not part of the range. So that is difference between what? Domain, codomain, and what? Image. So domain is the image that you are talking about, that I want to map. You understand? So why the codomain is the what? Is the one that is being mapped to. So in short, let me give you what is it called? The brief definition of domain and codomain. Codomain is just like the what? Subset of what? Of domain. You get? Codomain is like what? Subset of domain. While the elements in the codomain that have image in the domain are called the what? The range. So I'll see you see some examples later that I will give you under that. So let me see if I'm going to see one or two examples here. So let's look at this question. Let's look at this question under domain. codomain, and range. Let's see this question so that you understand better of what we mean by the question says find the domain, codomain, and range are of the mapping. So we are giving a mapping. So they say x is mapped to b to y and it's a function. X is mapped to y in a function. So this is the mapping. So we have -1, 2, 3, 4. So we have for y, we have 7, 5, 3, 0, -3. So the now say -1 is mapped to this. 4 is mapped to 7. 2 is mapped to 3. 3 is mapped to 5. So that's all. So we want to find the domain, codomain, and what? And the range. So it's very simple, as you can see. The domain D. So you'll be given by what? Your x. That's your domain. So -1, 2, 3, and what? 4. That's your domain. Then codomain C. Codomain C. You'll be given by what? 7, 5, 3, 0, minus what? 3. Then your range. Your range are the what? Are the elements in the codomain that have image in the what? Domain. 7 has image, right? 5 has image, right? 3 also have what? Image, and -3 have what? Image, but 0 doesn't have. That means you're having -3, 3, 5, and 7. This is your range. So hope you understand the difference between domain, codomain, and range now with this example. So there are some other examples like that they always give like this. It will be in terms of mapping. So that will ask us to find the domain, codomain. So let's see another example so that we now move to other stuff. So and another thing you need to know is that before I give this example, mapping is always represented by the arrow diagram. Don't go and use another line. You get? If you have to represent, like let's say this one now. Let's say you are giving this one now, and you have to represent it in a mapping form. So they say if they say the mapping is between x and y. You understand? So I want to represent this one in the mapping form now, giving domain, codomain, and range. I mean, the first thing you always write is your domain. The first thing you always write. You want to represent this in the mapping form. Your domain is this, Abi. So just write -1, Abi, 2, 3, 4. You get? Then you know that all these domains that I write, they are x, they are x, they are x, they are x. Abi, and all these codomain, they are what? Y, and what? Y. You get? So the next thing is what? You write your codomain. So you want to represent on the mapping, just write between domain and what? Codomain. So then your codomain will be what? You start from 7, 5, 3, 0, minus what? 3. Then you know that -1 is mapped to what? Okay, let me write it as it comes. -1 is mapped to what? -3, right? Okay, -1 is mapped to -3. So in another what's it called? It's always good to write from the lowest value. You get? So I didn't do now this one like this. I write it like this. I want to write it from the lowest value, which is what? Minus 3, 0, 3, 5, and what? 7. You get? So minus 1 is marked to what? Minus 3, Abi? So minus 1 is marked to minus 3. Then 2 is marked to what? 2 is marked to what? Okay, 2 is marked to 3. So because we don't have 0 in our mapping. So, but one thing you need to know is that if they will ask you to represent in the mapping form, they will have told you that this 0 is what? Or they will have told you that, okay, these values are what? Are range. So we are considering the range now. Minus 1 is marked to what? Minus 3, right? 2 is marked to what? 3, right? So 2 is marked to 3. Then 3 is marked to what? 5, Abi? 3 is marked to 5. 3 is marked to 5. Then the last one, 4 is marked to what? 7, Abi? 4 is marked to 7. So that means if they give you domain, codomain, and range, represent it between what? Domain and what? And range. So that once you represent it between domain and range, any other value that you are seeing in the codomain, you just write it there. So it can be at any place. You just write it there for them. That's all. So I always know that we use arrow line to represent our code, our mapping and function. So don't go and use another thing. So now let me see another example if I'm going to see. Okay. Alright, let's just continue. So you have got the differences between what? Between domain, codomain, and what? And range with this representation. So please know how to extract your domain, codomain, and range from a map. You get? And also when you are giving domain, codomain, and range, know how to represent it in a what? In a mapping form. You understand? So how do you represent between your domain and range? So each value you must write it in what? Ascending order. So that this first one will be mapped to this, second one will be mapped to the second one. Then all other values that you are seeing in the codomain that are not in the range, just write it in your map of what? Of Y. That's all. So the next thing we'll be talking about is types of mapping.